Okay, so these are the continuity examples that I'm showing you for extra practice for Tuesday's test. Here we go. The first one that I have, it says use the definition of continuity, so your three rules, to find the value of k in this one and the value of m in this one that will make this continuous everywhere. You're trying to make it continuous. Here's the k that you're looking for over there, and the m, and then just the k's over here. So you have piecewise functions that, depending on what those values are, it can be continuous. And there's a lot going on with these problems. Okay? Here we go. Let's go to number 8. The way I would want you to start is all about that what if moment. What if x equaled 2? For the first one, if x equaled 2, up here, what would I get? 4k. What would I get if x equaled 2 over here? 4 plus k. And for something to be continuous, it must make that ET moment per se. You with me? The limits must approach the same value. Thus, 4k must equal 4 plus k. So now that I solve this as a regular Algebra 1 problem, I get 3k is equal to 4, so k is equal to 4/3. You at least know what the answer is, but that's only one of 8 or 9 points. Okay, now let's use the definition to make this happen. We have 3 pieces to the theorem, of definition of continuity. Okay, where are we ideally going to start? Which one? 1, 2, or 3 if we're answering this type of question? Right? We're actually going to start at 3 because we're going to say that it will make it continuous everywhere. So rule 3 has to be true. And if rule 3 is true, we know the other 2 are true. Okay? So here we go. The limit of what? F of x as x is approaching what? 2. Okay, is equal to what? F of 2. That's where we start. Okay? Now when we go back up, 1 and 2, it doesn't matter what order you do them, but they both have to be true. So let's go back up and say f of what is defined? F of 2 is defined. And technically, this is the way I want you to do it on the test. Technically right now, what is f of 2 as it sits right now? It's 4k, right? F of 2 is 4k. Y'all with me the way I'm developing this? And at the very end, then you'll put f of 2 would be what? 8/3? Or no, not 8/3. 16/3. You with me? So f of 2 would equal 16/3. Because if you plugged in 4/3 for k, you would get 16/3. Are we good?
Why is it 4k, not 4 plus k?
Because this is a really good question. F of 2 is where it's equal to.
Okay.
So if I plugged in 2 right here, I would get 4k. Okay, I don't want you, if I only see 16/3, you didn't use the definition properly. I want you to use it with variables whenever they're needed and know when to plug it in to get your answer pieces. Now, the limit of f of x as x is approaching 2 must exist. Okay? And that's over here. And for it to exist, I need both one-sided limits to exist. So I need the 1 as you approach 2 from the left, and I need the 1 as you approach 2 from the right. Now, if I'm approaching from the left, it's the ones that are less than 2. So I'm going to use this, and what would I get anyway? I'd get 4k. Because I plugged in my 2 into this equation right here and got 2 squared is 4, 4k. Okay? Now, if I approach 2 from the right, if I approach 2 from the right, I'm looking at everything greater than 2. It's going to be 4 plus k. Right? And if you didn't already realize, this is what I did scratch work way earlier on.
Would you get points off if you like put the value of a into it and already selected out?
Here's what I'll say. I prefer you not to. I prefer you to do it like this with the variables, but I won't count off
I've
points.
been doing it like.
I won't count off points. But make sure that you show the work that I'm wanting to see both one-sided limits and that you're setting them equal to each other at one point in time. Because that tells me you know it has to be equal for the limit to exist. Okay? Any questions on that?
So what are all the points?
The points,
The parts that you write.
this would definitely be a small point. I'm going to be looking for this mention and then either one of those. Just like Luke was saying. I'm not necessarily going to count off if you put 16/3, but you forgot 4k. But I do want you to write it as far as going through the 3 steps anyway. Okay? I am looking for this, and I am looking for each individual piece. And then the most important one on this one is that. The only thing that I have not circled that is very important is what? That they're equal. Okay? All those pieces that I just circled are the ones that I'm looking for. And yes, these take a little bit to grade. I'm not going to give them back to you the next day. It'll probably be 2 or 3 days. Yes?
Is the what if a point? Yeah. Because I know it's been in the.
Okay, the what if is not a point. Okay, now I only encouraged it with group points because I wanted you to make it easier for yourself as how to start. But it's not technically a point because I made that up. That was me just trying to help you guys out of making this what if moment so you can see what you're trying to do.
What about your your written explanation, like your therefore?
Oh, okay. All right, thank you. Thank you. I missed that. So therefore,
Oh, yeah.
f of x would be continuous everywhere. You could say theorem holds. When theorem holds, it means all of these were true. Theorem holds, therefore f of x would be continuous everywhere. Okay? Now let's do this last one because it is the systems of equations. And I think for 4th period, guys, I will record the intermediate value theorem problems and then post them on the internet like that. Quickly. Alright, here we go. Number 9. Number 9, I'm looking for K and M on this one. This one's involved, okay? Please make sure that you know how to do something like this. M and K is what we're looking for, and we're trying to make it continuous everywhere just like before. And if you notice, I have how many what if moments? 2. I have what if x is equal to 2, and what if x is equal to -1. Here we go. If x is equal to 2, what would this equal? 9. If x is equal to 2, what would this equal? 5m plus k. And what are we saying that the relationship between these two answers will be? They will be equal. Remember, those are the 2 one-sided limits. The limit must exist. Now let's create the equation for the other one. See what I'm doing? I'm going to go over here to what if x was -1. So if x was -1 on this equation right here, whoops, what would that equation be, guys? 2m plus k. How about if x was -1 right here? -2 minus 1
It's -4.
is negative 3 plus 7 is 4. And we're saying that these are equal to each other. You with me? So they're all related with g of x. So these are not just one variable. And you learned way back in algebra 2, that when you don't have just one variable, you have to do a systems of equations to solve for two variables. So we have 2m plus k is equal to 4, and 5m plus k is equal to 9. Okay? Now I can go ahead and multiply, use elimination, so that I get a negative 5m, a negative 9, and a negative k. It does not matter what you do, just do the system. Solve the system of linear equations. So now when I add these, I'll get a negative 3m is equal to negative 5, so m is equal to 5/3.
We can still use like substitution.
Yeah. And now that you have 5/3, you can plug that in and say 10/3 plus k is equal to 4. 4 is the same as 12/3. Subtracting 10/3, k is 2/3. We know the answers already, but these are little pieces of the proof. Okay? Here we go. We're going to do two proofs real quick. I'm just going to do the setup, and then I want you to use example 8 to finish them off, because I'm running out of time. The rule. Let's do the x equals 2 moment here, and the x equals negative 1 moment here. What's the first rule, guys? So a lot of us, I just heard it, would have gotten it wrong. It's not f of x. It's going to be g of x, and not g of x, but g of c. What's my at moment here? 2. So I'm going to say g of 2 is defined. Okay, now again, I know, and that's maybe why there was a little hesitation, we have to start from rule 3 with this type of problem, because we're coming from a must-be continuous standpoint. So we're going to say the limit, help me out, of g of x as x approaches 2 is equal to g of 2. Okay, let's come over here. This one is the limit of what? G of x as x approaches negative 1 equals g of negative 1. Just wanted to go through this because I want you to get all of your variables in order. So let's do rule 2. I'm going to write small. The limit of g of x as x approaches 2 must exist. The limit of g of x as x approaches negative 1 must exist. Because I don't have room over here, I'm going to do this one to the right, and then it's just the same thing, guys, but with different numbers, okay? So make sure on the test that you do put on this step both one-sided limits. So you would say the limit of g of x as x approached negative 1 from the left and negative 1 from the right. Help me out. If I approach negative 1 from the left, which one, what would be my answer right here? If I'm approaching negative 1 from the left. Anyone? 4. And if I approach negative 1 from the right, what would it be? 2m plus k. And again, these are just two pieces that you get. If you never show the work that they were equal to each other, you need to make sure that you have these pieces, showing that that's what you're contemplating. Okay, so let's go back up to 1. What's 1 on this one right here? G of negative 1 is defined. looking at my original one, here's the equals. Here's where negative 1 exists. What would negative 1 equal, guys? What is g of negative 1 on this one? 4. Notice how this is not variables. This is not equations this time. Not for this specific one, because I didn't have an m or a k there. Okay? And yes, you would break this up and you'd show this piece. Let's go. What is g of 2? G of 2 is defined, and 2 is here. Be careful. See? So it's not 9. It's 5m plus k. And this is what I'm looking for. I'm looking... So let me come back. Let me come back a little bit. We just learned something right now that I'm going to change with Luke. If you wrote that other thing down, it's still the same. Like if you plug in m and k right here, and you wrote g of 2 is equal to whatever you get after you plug in m and k right here and here, from our answers that we had way down here at the bottom right, that would be acceptable. That would be okay. But I'm preferring the variable notation. Questions on this? Please study this. The intermediate value theorem is a little bit more, and I will record those in fourth period.
Can I take a picture?
Yep.